This video is about projectile motion by Jeremiah Pino and AJ Wilson. In this video, you will learn how to calculate horizontal and vertical motion when launched at ground level. So what is projectile motion? Projectile motion is a form of motion in which an object or particle is thrown near the Earth's surface and moves along a curved path motion under the action of gravity. As you see, in this slow motion video, the small volleyball is launched in the air by the force of my hand and travels in a curved path. It then falls due to gravity. Now it is time to apply math to this concept. When solving a problem about projectile motion, when launched at ground level, we first should make two columns, one vertical column and one horizontal column. After, under the vertical column, we label the 6 variables, which are acceleration, distance initial, distance final, time, velocity initial, and velocity final. In the horizontal column, we label 4 variables, which are acceleration, change in distance, time, and velocity. We then insert numbers that we know are a must-have in the columns. Distance initial and distance final under the vertical column always equals 0 because when the ball is launched from the ground, it starts at 0, and when it travels up in the air, it will eventually go back down to 0 due to gravity. Acceleration for the vertical column is negative 9.8 meters per second squared because gravity is a force acting upon the projectile while it is traveling. Acceleration for the horizontal column is 0 meters per second squared because there are no horizontal forces acting upon the projectile. Now that the given numbers are complete, we must use equations to solve for the rest of the variables. The problem must give you initial velocity and angle of the projection in order to finish solving. To calculate velocity initial and velocity final in the vertical column, use the given initial velocity multiplied by the sine of the angle, which are both numbers that the problem should have given you. Velocity initial should be positive because the projectile is traveling in a positive direction, and velocity final should be negative because the projectile is traveling in a negative direction. Both velocity initial and velocity final numbers should be the same, except velocity initial should be positive and velocity final should be negative. To calculate time in the vertical column, take the velocity final subtracted by velocity initial over acceleration. Now in the horizontal column, you must first find the velocity. Use the initial velocity multiplied by cosine angle of the problem. Both numbers of the problem should have been given to you. To find time, copy time from the vertical column. To find change in distance, multiply the horizontal velocity and time. After all calculations are made for both columns, add the unit of measurement to each number. Acceleration should be in meters per second squared, distances should be in meters, time should be in seconds, and velocity should be in meters per second. This concludes the math for projectile motion. I hope you enjoyed watching this video and learned more about projectile motion. Thank you for watching.